Hello, this is Geometry, topic 3-1 on angles. Let's go ahead and review some definitions first. A ray is an object that consists of one endpoint and continues infinitely or forever in one direction. Now if I have A and B, I would call that ray AB. And then I have an angle, which is an object made up of two rays that we call our sides that have a common endpoint, which we call our vertex. So we have A, B, and C. Now when we name this one, we're going to say angle. I'm going to say BAC. The reason is that A happens to be my vertex, so A needs to be in the center. Okay? These don't go in alphabetical order. The vertex goes in the center. Let's go ahead and start naming. So our sides, we have this one. So that is A, B. And we also have this one, which is BC. Then we have our vertex, which is B. And the name of this angle would be ABC because B is the vertex. Let's go ahead and look at example number 2. How does the diagram in example 1 differ from this diagram? Well, for instance, we have three rays. We're given 1, 2, 3 angles. All right? And so we're going to have to treat this a little bit differently. However, I need to back up to example number 1 real quick because while I can call this angle ABC, because it's a singular angle, I could actually just call it angle B. This is angle B because I know obviously that angle B has to be that angle. Now in example 2, I can't do that. All right? I actually have several parts. And so I have angle QPR. I have angle QPS. And I have angle RPS. I cannot say angle P because all three of these would be angle P. Now, what an angle does is an angle is two-dimensional, so it sits on top of a plane, and it breaks the plane into three parts. We have the interior, we have the exterior, and we have the angle itself. Basically, I have the inside, I have the outside, and I have the angle itself. Now, we want to name a point that was in the interior of QPS from example 2. So we have QPS, and an angle that is inside QPS would be R. And now we want an angle that is a point that is in the exterior of QPR. So we have QPR, and S is outside of QPR. Well, now we have another vocabulary term called adjacent angles. And adjacent angles are angles that have a common vertex inside, but no common interior points. So if I call that C, and X, Y, and Z, I would say that angle X, C, Y is adjacent to angle Y, C, Z. Notice they both share Y and C as a side, and they both share C as their vertex. So this angle would be adjacent to the angle. So going back to example 2, those two smaller angles were adjacent angles. And they've given you the description here. That would be QPR and RPS. And so we have this, that if I can take this part of the bigger angle and that part of the bigger angle and add them up, they'll equal the big angle. It's angle addition postulate. It basically says that angle QPR plus angle RPS equals angle QPS. Let's put that into motion. So this says that PQS, the whole thing is 77 degrees. QPR, that would be this one, is 32 degrees. And we want to find RQS. Well, this first one plus the second one would equal the large one. Go back to your algebra class, simple one-step equation. And if we do 77 minus 32, we get 45. And so this angle RQS, the measure of that angle, is 45 degrees. On to example number 5. Here they say angle AOC, the whole thing, equals 70. AOB is x plus 10. And BOC is x. And we want to find everything. Well, again, I can take this first angle, x plus 10, add the second angle of x, and I should get the total of 70. Going back to your basic algebra, 2x plus 10 equals 70. 2x equals 60. So x must equal 30. So, well, BOC was just x, so it's 30 degrees. And AOB would be 30 plus 10, which equals 40 degrees. And that's the angle addition postulate. The next thing I want to cover in our notes, just some more very basics on angles, is their classification. If we are less than 90, we call that acute. We are equal to 90, we call that right. If we are greater than 90, we call that obtuse. And if we equal 180, we call that a straight angle. Just vocabulary terms that you need to make sure that you understand. So as we move on to example number 6, we can completely identify everything. This would be angle F, or we could call it angle YFI. Its measure is 35 degrees, which is less than 90, so it would be acute. Here we have angle T, or we could call it angle LTC, which measures 125 degrees, which is greater than 90, making it obtuse. One more page. Here we have angle T, or we could call this angle RTS. This box means that it is 90 degrees, so we call this a right angle. And here you see a line, and that would be correct, but it would also be angle X, or angle NXS, which measures 180 degrees because this is a straight line, and so this would be a straight angle. We have one more vocabulary term that we need to talk about, and that would be an angle bisector, which is a line radius segment that divides an angle into two congruent angles. What this means is that this part is the same size as that part. Okay? So we look at this, and it says that FG bisects EFH. So that means that this and this are the same size. Now we work with it. EFG is 5x minus 10, and GFH is 3x plus 25. Well, because we know that these are congruent, I can go ahead and set them equal. So 5x minus 10 equals 3x plus 25. Again, we go back to our basic algebra. I get that 2x equals 35. And when I divide 35 by 2, I get that x equals 17.5. And now here it says that GFH, 3x plus 20, and EFG, 4x plus 80. Again, these are congruent. So 3x plus 20 equals 4x plus 80. Go ahead and begin to simplify. I get that negative 60 equals x. And so x must equal negative 60. Now, I know I have a ridiculous answer here. We don't expect x to ever be negative, especially as this makes our angles negative. However, that's just how this one came up. This must be an imaginary realm to give us this crazy number, but it does check out. So this is the measure of our angle. Good luck with all these terms, remembering them. Make sure that you refer back to your notes on your assignment so that you have something to look at. Good luck and have a good day.